This is the second problem for determining the rate law, and this time we're also going to do the rate constant. So probably the most difficult part of this problem for students is to determine which lines or which experiments to use. I'll use those two terms interchangeably, line versus experiment. So when I start this, okay, so for A, okay, remember for the one that I'm interested in, so I'm interested in A for this part, I'm looking for the one that's different. So that means my choices are 2 and 1 and 2 and 3. Then I go to the component that I'm not interested in, which in this case is B, and I look for which one's the same. So 2 and 1, those are the same, so that's a possibility, but 2 and 3 are not the same, so I cannot use 2 and 3. So then I start my problem. The highest concentration goes on top, so I'm looking at these two here, and I'm going to use these two here. The highest concentration on top, so it's going to be the concentration of A for experiment 2 over the concentration of A for experiment 1. And I'm writing this one different than the one I did in class because I'm now putting the M, the unknown, outside of parentheses instead of doing M over M. And this is going to be the rate for experiment 2. So these two things right here must be the same over the rate for experiment 1. And then I just plug in numbers. So the concentration for experiment 2 was 0.100 divided by the concentration for experiment 1, which is 0.050. And what I don't know, you must have an unknown in your equation, is M. So the rate for experiment 2 is 8.0 times 10 to the minus 3. Rate for experiment 1 is 4.0 times 10 to the minus 3. So I do this math. 0.1 divided by 0.05 is 2 raised to the M. 8.0 times 10 to the minus third divided by 4.0 times 10 to the minus third is 2. So M must equal 1. So I raise 2 raised to the 1 is equal to 2. Okay, I do the same process for B. Okay, so I look for the one in B that's, let me change colors here. I look for the one that's different in B, and that's number 3. So it could be 3 and 1, so this is for B. Or it could be 3 and 2. So those are the ones that fit the first criteria. Then I come over here and I want to look for the one that's the same as a 0.05. Okay, so 3 and 1 fit that criteria, but 3 and 2 do not. So I'm going to cross out 3 and 2. And then I want the highest concentration. Now I go back and now that I've decided that, I don't need to look at A anymore. I'm just looking at B. Okay, so the one with the highest concentration is 3. So experiment 3 on top. Okay. And so it's going to be the concentration of B for experiment 3 over the concentration of B for experiment 1 raised to the, since I'm doing B, it's N this time. Okay, and then it's rate for experiment 3 over rate for experiment 1. So this time I'm using this one and this one, which corresponds to this one and this one. So now I put my numbers in. So I have, again, 0.1 divided by 0.05 raised to the N is 1.6 times 10 to the minus 2 divided by 4.0 times 10 to the minus 3. Okay, and so N, so I divide these two and I get 2 to the N. 1.6 times 10 to the minus 2 divided by 4.0 times 10 to the minus 3 is 4. Okay, so N, what power does 2 get raised 2 to equal 4, and the answer is 2. So therefore, my rate law, which is the first part of this question, my rate law is rate is equal to K times concentration of A, and I don't need to write anything because it's 1, times the concentration of B squared. So that's the answer to the first question there that it asks up here. It says, what is the rate law for this reaction? So this is that answer right there. The second part is that I need to determine the rate constant, which we haven't done yet in class. Okay, so for the extra credit, this is all I ask you to do. Okay, but to determine the rate constant, I'm going to go back and erase this side over here so I have some room to work. Keep going here. Okay, so determine K, I'm going to use any experiment. So any experiment. So for experiment 1, then I'm going to basically plug in the numbers for this. So it's going to be the rate for line 1, or experiment 1, is K times concentration of A for experiment 1 times concentration of B for experiment 1 squared. So basically it's exactly what I have written down here. And now I plug in the numbers. So it's 4.0 times 10 to the minus third is K, which is what I don't know. Concentration for experiment 1 was 0.05 times 0.05 squared. So this ends up being 4 times 10 to the minus third. The left-hand side becomes 1.25 times 10 to the minus fourth, K. Divide both sides by 1.25, so I have 4.0 times 10 to the minus 3 divided by 1.25 times 10 to the minus fourth is equal to K. So K, I don't want to do this. How do I get out of that? Okay, let's see if I can escape out of that. Oh, there we go. Right up here, K ends up being 32. Okay, like I said, I can do that for any experiment. So erase all this. Wish there was a big way to erase, but there's not. So for experiment 2, basically the same thing. It's going to be rate for experiment 2 is K times concentration of A for experiment 2 times B for experiment 2, but it's also squared. So it's going to be 8.0 times 10 to the minus 3 is K times 0.10 times 0.05 squared. 8.0 times 10 to the minus 3 ends up being 2.5 times 10 to the minus fourth K. Divide both sides by the 2.5, so I get 8.0 times 10 to the minus third divided by 2.5 times 10 to the minus fourth is equal to K. So K also ends up being 32. If I did this for experiment 3, which I'm not going to work out, but for experiment 3, K would have also been equal to 32. Okay? So for the test, if you know how to do this once, you know how to do it 3 times. So I usually only ask you to do it once. And that now answers, so 32 is the answer for this. The answer for this was rate is equal to K times concentration of A times concentration of B. Because a lot of times on the B squared, a lot of times on the test, students forget to actually write out what the rate law is. So they lose a point or two because they haven't written the actual answer. Okay? So we will do another problem in the next video.